welcome to Physics 2020. So this is the fourth section in the topic that is projectile motion in an inclined plane. So in the first two sessions we have discussed the theory of that is projectile motion in an inclined plane. So in the first topic, first session we have discussed what is projectile motion and what are the component vectors of that is projectile motion we have discussed. In the second session we have discussed that is we have derived the expression for time of flight, maximum height and horizontal range, horizontal range of projectile motion in an inclined plane. So in the third session we have discussed that is two numericals of projectile motion, projectile motion. So in this section we are going to discuss two more numericals, in the same topic, So let us see the third numerical. So a projectile is thrown with a speed u at an angle theta to an inclined plane of inclination beta. Find the angle theta at which the projectile is thrown such that it strikes the inclined plane horizontally. So the same problem we have solved, that is in the it strikes the inclined plane normally, normally. So what is the condition for the angle of projection, or what is the angle of projection theta such that it hits the inclined plane normally? In the last class we have solved the numerical, So here we have to solve, that is to find the angle theta. Here also we have to find the angle of projection at which the projectile is thrown such that it strikes the inclined plane horizontally. So what is the condition for, or what is the angle of projection? Angle of projection we have to find. So see, it is an inclined plane, It is an inclined plane. So of angle, that is beta, of angle of inclination is given, that is beta, So from this one projectile, one particle is projected, projected at an angle theta with the initial velocity u, with the initial velocity u. So the angle of projection is theta, theta. So it hits the inclined plane horizontally, horizontally, horizontally. So horizontally hitting the inclined plane horizontally means it has only horizontal component of velocity. So we know that that is in a projectile motion, that is the projectile undergoes two types of velocity, So in each and every point of the trajectory, the projectile undergoes two types of velocity, that is horizontal motion as well as vertical motion. So horizontal velocity is there, vertical velocity is there. So here when it hits the inclined plane horizontally means it has only horizontal velocity. Its vertical velocity is equal to, so this is the horizontal velocity Vx. Its vertical velocity is equal to 0. Vy is equal to 0. That is the first condition we have to understand. Yes. So what are the component vectors in the, that is we know that in a that is projectile motion horizontal, that is inclined plane. So the inclined plane will be taken as x-axis, x-axis, and this is our y-axis, y-axis. So theta is the angle of projection, so this component. So the horizontal component is u cos theta, and what is the vertical component of, that is u sin theta, u sin theta. So the horizontal acceleration, so acting in this direction, that is g, g sin beta, and vertical, so vertical acceleration, that is g cos beta. So these are the different components of a projectile. So we have discussed that is how to find the component vectors in the first session, first section. So So what about this distance? So the inclined plane, that is the horizontal range, capital R, clear, capital R. So the horizontal distance travelled by the projectile. So it hits the horizontal, that is inclined plane at this distance. So what about this distance? This distance, it is the maximum height of the projectile. Okay, maximum height of the projectile when it is observed from the ground plane, not the inclined plane. Okay, when it is observed from the ground plane. Okay, ground plane. So actually like that, that is, it is when you extend this. So extend this. So the projectile will come like this. Okay, it is like this. So the projectile hits the inclined plane at the point, that is the maximum height of the horizontal projection. Okay, in horizontal projection a particle is projected horizontally with an angle theta, with a certain angle. So it reaches a maximum height. At that point only, that is the projectile will hit the inclined plane horizontally. Okay, horizontally. So how we can prove that? That is this is the maximum height of the, that is horizontal projection. Okay, horizontal projection. We can prove that. So how much time? This is the time of flight. Okay, in horizontal projection. So very important. We are observing this projection from the ground plane. Okay, ground plane. So this much the time taken for this entire projection. So entire projection is, that is time of flight. Okay, time of flight. So time of flight, we know the formula, that is t is equal to 2u sin theta divided by g, the horizontal projection. Okay, horizontal projection, t is equal to 2u sin theta divided by g. So theta is the angle of projection. So when it is observed from the ground plane, so what is the angle of projection? That is theta. Here theta is the angle of projection for the inclined plane. When it is observed from the ground plane, what is the angle of projection? That is theta plus beta. Am I right? Theta plus beta. So t is equal to, we can write, that is 2u sin theta plus beta divided by g. Okay. So this is the total time taken by the projectile to reach the ground. So what is the half time? That is time for reaching the maximum height. So we know that, that is, it is nothing but, that is t is equal to u sin theta plus beta divided by g. So when we study about, that is the horizontal projection, that is we have proved this. That is, it takes the half of the time to reach the maximum height. Okay. Or we studied, that is the time taken by the projectile to reach the maximum height is equal to time taken by the projectile to go to the ground. Okay, upward motion or downward motion. Okay, so t is equal to u sin theta plus beta divided by g. So when it is observed from the ground, so I am using the kinematic equation, that is Vy is equal to uy plus ay into t. So Vy is equal to uy plus ay into t. So when observed from the ground plane. Okay, ground plane. So that is vertical velocity is equal to 0, is equal to uy, that is horizontal component of velocity. Okay, horizontal component of velocity. So that is u cos. So vertical component of velocity. Okay, vertical component of velocity from the ground plane, that is u sin theta plus beta. Theta plus beta. The doubt is there, that is, suppose the projectile is here. Okay. So this is a horizontal projection. It is projected like this with the angle, that is theta plus beta. So this is the x-axis. This is the y-axis. So horizontal, that is with the initial velocity u, that is u cos theta plus beta. What is this component? That is u sine theta plus beta. So vertical component of velocity u sine theta plus beta plus ay minus g, okay, minus g into t, okay. So minus gt, when you come this, that is plus gt is equal to u sine theta plus beta. So from this t is equal to u sine theta plus beta divided by t, sorry, divided by g, okay, g. So this is the time taken by the projectile, so to reach this point, okay, to reach this point. So this point only, that's the vertical velocity is equal to 0. Using this condition we have found the time, okay. So time is equal to u sine theta plus beta divided by g. So from this what we can understand? Yes, it is the maximum height of the horizontal projection, okay, maximum height of the horizontal projection. So at the point, that is the maximum height of the horizontal projection, it hits, that is the projectile hits horizontally, okay, horizontally. So now, so what why I am telling this, that is it is nothing but this distance is nothing but that is h max, okay, h max, okay, h max, because we are going to find the condition, that is theta, angle of projection, by observing the projectile in the ground plane, okay, ground plane, then only we can find the condition for theta, okay. So this distance is nothing but that is h max, okay. So what about this distance? This distance is nothing but that is the horizontal range, that is the horizontal distance traveled by, when the projectile is projected from here and it reaches the point. So how much distance it traveled in the horizontally, how much distance it has traveled when it is observed from the ground plane. So this much distance, this is the horizontal range, okay, in the ground plane, okay, horizontal distance, horizontal range. Okay. Now we have to find, that is, I am considering this triangle, okay, this triangle, that is O, I am considering this point as A and this point as B, okay, this point as B, considering this triangle. So it is a right angle triangle, so from this right angle triangle, that is sine beta is equal to opposite side, that is h max, divided by hypotenuse, that is capital R. So R sin beta is equal to h max. So what is the formula for that is h max in horizontal projection, okay, horizontal projection? u square sin square theta, that is formula is, that is u square h max equal to, what is the formula in horizontal projection, that is u square sin square theta divided by 2g, okay, u square sin square, what is here angle of projection, theta plus beta, okay, very very important, theta plus beta divided by, okay, divided by, that is 2g, okay, 2g. Shall we write this? That is R sin beta is equal to h max u square sin square theta plus beta divided by 2g. Take it as equation number 1. Okay, equation number 1. So I am from this triangle, right angle triangle, I am finding that is R cos beta, okay, R cos beta is equal to adjacent side. So adjacent side is the horizontal range, adjacent side by hypotenuse, that is capital R, okay, capital R. So cos beta, okay, so cos beta is equal to, so from this R cos beta is equal to, that is horizontal range. So what is the formula for horizontal range? That is horizontal projection. Okay, so horizontal projection, what is the horizontal distance traveled by? Suppose a projectile is projected with the angle theta plus beta. So what is the horizontal range? That is u square sine 2 theta, theta plus beta, u square sine 2 theta divided by that is g. Clear? G. So take it as equation number 2. Equation number 2. Clear? U square sine 2 theta divided by g. So just remember the formula. Okay. U square sine 2 theta divided by g. Here theta is theta plus beta, angle of that is projection, theta plus beta. When it is observed from the horizontal plane, okay, horizontal plane or ground plane, what is the angle of projection? Theta plus beta. So theta is the angle of projection in the inclined plane. So when it is observed from the ground plane, what is the angle of projection? Theta plus beta. So r cos beta is equal to u square sine 2 theta plus beta divided by g. So equation 1 divided by 2. Okay, 1 divided by 2. One divided by 2 implies, that is r sin beta divided by r cos beta is equal to, okay, so u square sin square theta plus beta divided by 2g into, so reciprocal, g divided by u square sin 2 of theta plus beta. So u square get cancelled, g get cancelled. Okay, so this r get cancelled. So from this what we can write? Sin beta by cos beta, that is tan beta, sin beta by cos beta, that is tan beta is equal to, so sin square theta plus beta divided by, so 2 into, we can write that is sin 2 theta, 2 sin theta cos theta, 2 sin theta plus beta into cos theta plus beta. Okay, so we can write that is tan beta is equal to, so 1 sin square, this sin theta plus beta can cancel. Okay, so tan beta is equal to sin theta plus beta divided by 4 into that is cos theta by cos theta plus beta. Okay, so we can write, so tan beta is equal to, so 1 by 4 into, okay, 1 by 4 into sin theta plus beta divided by cos theta plus beta, that is tan theta plus beta. Okay, tan theta plus beta. So remember that is we have to find theta. Okay, we have to find theta. So what to find the angle theta at which the projectile is thrown such that it strikes the inclined plane horizontally, we have to find theta. So remember that is tan theta plus beta. So from this tan theta plus beta is equal to, okay, so I am writing here so from this tan theta plus beta, tan theta plus beta is equal to 4 tan beta. Okay, so from this theta plus beta is equal to tan inverse of 4 tan beta, 4 tan beta. Okay, 4 tan beta. So we have to find theta only. So theta is equal to tan inverse of, okay, tan inverse of 4 tan beta minus beta, okay, beta. So I'm rewriting this, that is theta is equal to tan inverse of 4 tan beta minus beta. So this is the condition, or this is the angle of projection, okay, angle of projection such that it hits the that is inclined plane horizontally, or this must be the value of the angle, okay. Theta is equal to tan inverse of 4 tan beta minus beta. Then only, that is, the projectile will hit the inclined plane horizontally. Clear? So the next problem, fourth problem. A particle is thrown at a time t is equal to 0 with a velocity 10 meter per second at an angle of 60 degree with the horizontal from a point on an inclined plane, making an angle of 30 degree with the horizontal. The time when the velocity of the projectile becomes parallel to the inclined is. So options are given, that is 2 by root 3 second, 1 by root 3 second, root 3 second, and 1 by 2 root 3 second. So this is an inclined plane, okay, inclined plane of a particle is thrown at a time t is equal to 0 with a velocity of 10 meter per second at an angle of 60 degree with the horizontal from a point on an inclined plane, making an angle of 30 degree with the horizontal. So this angle is 30 degree, okay, 30 degree. So projectile is projected from here, okay. So 60 degree with the horizontal. So this angle is 60 degree. Okay, so this angle is 60 degree. The velocity 10 meter per second. So this velocity is 10 meter per second. Okay, it's that this is the trajectory of the projectile. Okay. So what are the components of this? So this angle is in an inclined plane, okay. So this angle is 30 degree, so this angle is 60 degree. So definitely the angle of projection in the inclined plane is, that is 30 degree, okay, 30 degree. So how, this is the x-axis and this is the y-axis, right, y-axis. This component is, that is 10 cos 30, this component, it is 10 sin 30, okay, 10 sin 30, this g sin 30, g cos 30, okay, cos 30. So what we have to find, these are the component vectors of the, okay, projectile motion. So the time when the velocity of the projectile becomes parallel to the inclined plane. So when it reaches the maximum height, so this is the maximum height reached, okay, maximum height reached. So at this point, it has only horizontal velocity, okay, horizontal velocity, its vertical velocity becomes 0, okay. So at that time, that is, the projectile is parallel, okay, so the velocity vector, okay, velocity vector. So it has only Vx vector, Okay, so all other points it has, that is both horizontal vector and vertical vector. So in this point, that is the vertical velocity is equal to 0. Okay, so the vertical velocity becomes 0. Vy is equal to 0. So it has only horizontal velocity. Okay, horizontal velocity. So we have to find, that is the time when the velocity of the projectile, so velocity of the projectile becomes parallel, okay, parallel to the inclined plane, okay, inclined planes. So at all other points, that is it has both horizontal velocity and vertical velocity, it's not parallel. So the resultant velocity is not parallel. So and when it reaches, that is the projectile reaches its maximum height, so it has its vertical velocity is equal to 0. It has only the horizontal velocity. Still it has horizontal velocity. So at that time the horizontal velocity is parallel to the inclined plane. Okay, inclined plane. So using that condition we are going to solve this problem. That is at this point, that is when the projectile reaches at this point. So the projectile is at this point, okay, at this point A. So we can call it. So this point as O and this point as A, okay, A. So its vertical velocity Vy is equal to 0, okay. So Uy, so I am going to use this kinematic equation, that is V is equal to U plus At. So vertical velocity, that is vertical component, so Vy is equal to Uy plus Ay into T, okay, A into T. So Vy is equal to 0. Uy, that is the velocity in the vertical component of initial velocity, that is 10 sin 30, okay, 10 sin 30, okay. Ay, acceleration in the vertical direction, so this is the acceleration in the vertical direction, that is g cos 30, g cos 30, okay, minus g. So minus g, Ay is equal to minus g cos 30, because it is acting in the negative y axis, okay, minus g cos 30. Okay, so t is the time of flight we have to find, okay, t is the time taken by the projectile to reach this point, okay, so we have to find that. So Vy is equal to 0 is equal to, what is Uy, that is 10 sin 30 plus minus g, so minus g cos 30 into t, okay. So this minus negative term, so I am bringing this side, so g cos 30 into t is equal to 10 sin 30. So what is the value of g? G also 10, so 10 cos 30 into t is equal to 10 sin 30. So 10, this 10 cancel, okay. So t is equal to sin 30. So it is given, that is in this question is given, that is g is equal to, okay, g is equal to 10 meter per second square, okay. So t is equal to sin 30 divided by cos 30, so that's equal to sin 30 1 by 2 into cos 30 root 3 divided by 2, so 2 by root 3, okay, that is reciprocal, 2 by root 3, so 2 get cancelled, that's equal to 1 by root 3 second, that is the answer. So time taken by the projectile to reaches this point, okay, reaches, or the velocity vector parallel to that is the inclined plane is, so what is the value, that is 1 by root 3 seconds. So option A 2 by root 3 second, option B 1 by root 3 seconds. So this is the answer. Clear?